What's up everyone, and welcome to day 7 of our Juniper Networking series. In today's video, we will be talking about BGP. So as we know, we have two different flavors of BGP. We have iBGP and we have eBGP. iBGP is ran within an autonomous system, and eBGP is ran between two different autonomous systems. So both of these protocols are what we call dynamic routing protocols. So what are the benefits of using a dynamic routing protocol? Well, basically, we would configure two neighborships, or one neighborship, I should say, between both of these devices. And then after that, they will be able to exchange routing information. So if we didn't have the benefits of dynamic routing protocols, we as network administrators and network engineers would have to configure static routes for all of our routes in our routing table. And as we know, when we're dealing with enterprises, these routing tables can become huge. So the network overhead of configuring static routes would be very cumbersome on a network administrator or a network engineer. So instead, engineers develop dynamic routing protocols to bring down the network overhead for network engineers. So BGP has different attributes that you can use to manipulate how routes are sent out to different organizations, and also how routes are received back from different organizations. So these attributes are called well-known mandatory and well-known discretionary. And we could do a video in the future about these attributes. If you want to, you can go out and read up on some of these attributes and how to manipulate them within your network device. But in this video, we're going to try to keep it basic. We're going to be talking about the different states that the BGP neighborship is going to go through. So we have the idle state, we have the connect state, we have the active state, we have the open sent, open confirmed, and then ultimately we want to get to the established state. So when we have an established state, that basically means that both of these devices' neighborship is up and they are actively exchanging routing information. So that is what we're going to be looking at in this video. And then also, we are going to configure one of these switches to have a network off of it. So we're going to view the routing table of the other switch, and we shouldn't see that route at first. Then we're going to bring up the neighborship, make sure that our switches are in the established state for BGP, and then see if that switch can now see that network that we configured. So without further ado, let's hop into this video. Alrighty, so let's go ahead and log into our device. Let's get it going. All right, let's do a CLI. All right, perfect. So let's do a show route. Let's do a show route to view our routing table. And if you guys remember, in the last video, we configured our INET addresses. So we took the Ethernet switching interfaces off, and we configured INET addresses for both of the gigabit 000 interfaces. If you guys are confused about that, please go back and watch the last video, because we are going to start this BGP video from where we ended off on that video. So what I'm going to do is I'm going to connect my computer into the gigabit Ethernet 001. If I do a show interfaces terse, yeah, the gigabit Ethernet 001 is the one that we configured this /24 network on. So I'm going to connect my laptop off of this interface right here, and we're going to configure a IP address on my laptop. And then we're going to see if this top switch is able to see this network without a dynamic routing protocol being configured. So let's go ahead and hop onto my laptop, plug it into this top switch, and configure an IP address. All right, so let's connect our Ethernet cable into the USB-C right here. And I have that connection right there. And we're going to connect into this bottom port. Oh, no, we're going to connect into this port, 001. I almost went into 2. As we know, Juniper starts at 0. So we want to connect right there. All right. Now let's go to our Ethernet connection. Let me just move the camera a little bit closer so you guys can see that a little bit better. So this is the IP address that we put on this interface, 40.0.0.2, a /24 bit subnet mask. and our router is the switch IP that we configured. So now let's hop back onto our command line and check the network on the top switch to see if it's able to see the 40.0.0.0/24 network. All right, so let's connect or take our console cable out of our bottom switch. Let's plug into our top switch. All right, let me log in. Let's log in this root and let's do a password. All right, perfect. Now let's do a CLI. And of course, on that on that bottom router, we were able to see the 40.0.0.1/24 network. And that is because it is a local, we configured the local IP address. So it has a local route. So of course it's going to show in the routing table. Let's see if the top switch can see that route. So let's do a show route. And we cannot see that network over on the top switch, and that is because we have not configured a dynamic routing protocol between these two switches. So if I try to ping this PC, we do not have a route, so as a result the pings are going to fail. So now let's go ahead and configure a dynamic routing protocol between the two switches, see if it exchanges that 40.0.0.0/24 network, and then we're going to take a look at the routing table again. So let's hop into the configuration on how to configure BGP. All right, so the first thing we want to do is create our BGP group. So let's do an edit. And let's do a edit protocols BGP. Oops, I spelled protocols wrong. Protocols BGP group. And we're going to call it Ben's BGP group. That's the name of our BGP group. All right. Now, the first thing we want to do is specify that we're going to be using eBGP. So we're going to do a set type as external. All right. That's the first thing. The next thing we want to do is set our local autonomous system. And we named this switch right here AS600. So that is going to be the autonomous system for this switch right here. So let's do a set local AS600. Perfect. The next thing we want to do is configure the local address on this switch. And as we can see, the local address is .1 for this switch. So let's do a set local address. And we want to set it to 50.0.0.1 and hit enter there. And then the next thing we want to do is set our IP address for our neighbor. So we want to do a set. We want to do a set neighbor, and we want to do a neighbor of 50.0.0.2 because that is the other IP address of our neighbor. And we want to specify that the peer AS that our neighbor is going to be in is autonomous system 500. All right, perfect. Now let's go ahead and commit and quit these changes. And it's telling us that we need a license for BGP, but this is in my internal network. I'm not running this over the internet, so we should be fine. Perfect. Our commit was successful. Let's go ahead and move on to the bottom switch and do a similar configuration. So let's unplug. Oops, you guys cannot see that. Let's unplug from top, go into the bottom, and run similar commands over on this switch. So let's do an edit protocols. Oops, edit protocols. Oh, I'm not even in configuration mode. Let's do edit first. Let's do an edit protocols BGP group of Ben's BGP. All right, and we want to set the version of BGP to external. So let's do a set type external. Let's set the local AS on this one. So set local autonomous system. That's 500 on this switch. Let's do a local address. Let's do a set local address. Local address of 50.0.0.2. No, .1. It should be .1. Let me confirm. Let me do a run show interfaces terse Yeah, so it's .1 on, or .2 on this one. Yeah, so it should be .2. Let me do a show route, or run show route. And yeah, so it'll be .2. So let's do a set local address 50.0.0.2. All right, and let's set our neighbor. So set neighbor, and our neighbor is 50.0.0.1, and the peer AS that neighbor is going to be in is autonomous system 600. Perfect. So now let's do a commit and quit. All right, perfect. Now let's do a couple commands. Let's do a show BGP, and let's do a context sensitive help. Let's do a show BGP summary. So we can see right now that our state is in the active state, and that is one of the states that we went over at the beginning of this video. Okay, so we can see that we have one peer. It is down right now. We have one peer group, and that neighbor or that peer is down right now. So it's trying to transition through those different states that we had specified at the beginning of this video. Okay, let's continue to run it. And BGP is one of those protocols that takes a while for it to come up. All right, so now let's do a show BGP neighbor. All right, so we can see that our peer IP address is 50.0.0.1. Our local address is 50.0.0.2. Our state has now reached the established state. The last state that we were in was the open confirmed state. And we can see a lot more of statistics within this output right here. So we do have the neighborship up, but if I check the top switch again's routing table, we will not see that 40.40.0/24 network. And that is because we did not set the policy options to be able to send this route. So let's connect back into the top switch. All right, we're in. Let's do a show route just to prove my point. And we still do not see that route, but we do have a active, or I should say an established, let me use the right terminology. We do have an established connection between both of the switches. So let's set that policy option and then see if we're able to see this route. So before we set our policy statement, let's do a show route. Right, quit. And this is the route that we want to send, this directly connected route. So direct, we need to pay close attention to that because we're going to specify that inside of our policy option. So let's go ahead and set our policy option. Let's do an edit. All right. And let's do a set policy options, policy statement. And we want to name it send 40.0. And we want to do term 1 from protocols direct. So this is where we specify the direct route right here. All right, let's hit enter. And let's hit the up arrow. And then we're going to take away all of the writing until we get to the term. And then we want to do a then accept. All right, and that is perfect. So now the last thing we want to do is set this export within our BGP group. So let's do an edit protocols, BGP group, bins BGP, and we want to do a set export send 40.0 because that is what we named it right here. All right, let's do a commit and quit. Let's do a commit and quit. All right, so the moment of truth. Let's go back to our top switch. Let's go back to our top switch. Connect in. And let's see if we can see that route. Now, let's do a show route. And now we are able to see our BGP. Well, we can see that we have a route from BGP its preference is 170, and we can see that we are able to see the 40.0.0/24 network now. So now if I do a ping, let's try to ping this computer. And remember, we set that IP address to 40.0.0.2. We have a route for it now. Let's say enter. And we are now getting replies from our computer. So that is how you set up eBGP between two different routers in a lab, and how you can confirm that routes are being exchanged once that neighborship is up. So I appreciate you guys for tuning into day 7 of our Juniper Networking series. Hope to see you in day 8. Until then, peace out.